Hello, everyone, and welcome back to week two. By now you've gone through week one and you've taken all the introduction lessons about LLMs and you know the different types of LLMs. But you might be asking, how are these models generating answers? It feels like magic when you are giving your LLM a prompt and it just starts answering or starts generating a lot of text. In this lesson, we will reveal the magic that's happening. And turns out it's not, there is no magic at all. It's basically a classification problem. So whenever you are taking an introduction course to machine learning, they always make this distinction between regression and classification problems in supervised learning. And a classification problem is basically when your model takes some features and it gives you an output class. Turns out in our case, the features is just a sentence or a prompt. And the classes that the model is trying to predict are like the tokens in the entire language. The model will generate probabilities for every token that it has seen during training. So in this lesson, we will show that this is actually happening. And in future videos, we will also cover how it is actually happening to some degree of depth. So yeah, let's get started. So let's start with our code here. This is a Jupyter notebook. You can run it on Google Colab or locally. It's not a heavy one, so it doesn't matter that much. And it depends on the LLM that you choose. We'll start by installing the packages and doing our regular imports. And the first thing we do is we load our LLM. In this case, I'll be working with LLaMA 3.2 1 billion parameter. But feel free to change it and experiment with multiple LLMs. First we have some helper methods. The most important one is this one here, which is actually running the LLM and computing the probabilities. This is the most important part in the code. However, don't focus on this right now. We will cover it in a separate video on its own, and we will go into some details on what these lines means. But for now, take it as a method that takes in some string and it gives you some probabilities, or the top 10 probabilities in this case, of the tokens that the LLM think should come next. And then we have some other code that creates the charts for us. So most of these things are actually written by an LLM, so I won't go through them. So try to focus on the main idea that we are trying to explain here. So here we have the example, the cat sat on the, and then the task of the LLM is to predict what the next token will be. So here we have this visualization. On the left side, we will have the most probable tokens, things that the LLM gives the highest probabilities and think that these tokens should complete the sentence. And on the right-hand side, we have the lowest probability tokens. So let's take a look at the highest ones first. This is a very known example that's used a lot in tutorials, the cat sat on the mat. The LLM has seen this in training, of course, and it thinks that the token mat is the most probable and gives it the probability of 72%, and then follows the token table with 1.5, lap with 1.4. And you can see that the top three tokens all make sense in this context. The sentence would work if you used any one of them. And on the right side, you have tokens that have probabilities close to zero. So some of these tokens are very strange. Some of them we don't even know what this is, but it's something that the model has seen during training. Some of them are actually not even English, and this is because the LLaMA model is trained on different languages. So you can see the probabilities here are very, very small. So 2.8 times 10 to the power of negative 13. This is basically very close to zero. So all of these probabilities are, all of these tokens are considered zero probability tokens, which means the model would never predict these things in this context. However, the idea here was to show you that the model would output probabilities for everything in the vocabulary, for all the tokens that it has seen. And this is basically what any classification problem is. So you're probably used to binary classification, where you have two classes, or multi-class classification, where you have 3, 4, 5 classes. This is exactly the same. The difference is the number of classes here is very huge. So every token in the language is considered a class. And all of these tokens are given probabilities, even if they are very strange tokens or tokens that would never be predicted in this context. Probabilities would still be computed for these tokens. So if you look down here, you'll see that the vocabulary size for this model is 128,000 tokens, which means these are the tokens that it has seen during training. And this is the number of classes that we have in this classification problem. So let's take another example where we say the cat sat under the, and then we take a look at the probabilities. So you'll see they completely change. So Matt, which used to be the first token, now dropped to 4th place, and it only has 2%. And the most probable one became table, which makes sense because a cat, like, it's more obvious to sit under the table, not under a mat. And tree and bed are also high, they are having high probabilities. So you can see that changing a single word in the prompt can alter the behavior or completely change the output probabilities of the LLM. So we also have a comparison that is side by side. So if you give the LLM these two examples, they went to the professors and they went to the universities, and you let the LLM figure out the completion. So they went to the professor's house, office, home. So you can see all of these tokens actually make sense. However, house got the most probability. And the other example, they went to the university's library, university's campus, university's website. So you would see these also make sense in this context. So again, changing a single token at the end of the prompt completely changes the context and hence will change the behavior of the LLM and the output probabilities. So finally, we have a very cool interactive tool that I want you guys to play with. So when you run the last cell in the notebook, it's going to output some link. So if you visit this link, you'll find an interface where you can put in any prompt here, and then you can see the output probability. So you can play with this and try different things. So let's try an example where we say Paris is the capital of, and then we will let the LLM figure it out. So you can see it predicted France with a very high probability, and then other tokens. And if you change Paris, let's make it Madrid, for example. And you'll see the output probabilities will change, and now Spain is the top token. You can also try some other fun things, something like the famous rule E is equal to MC squared. So let's see how it would predict that. So it predicted the number 2 just because E is equal to MC squared. But also here you have this strange symbol. So it's a small 2. So it looks like a power of 2, which actually makes more sense. And in the third prediction, you have this symbol, which is in programming, it indicates to the power of symbol. So this means that the model has probably seen this in many different ways, like E is equal to MC2 or MC to the power of 2, which is actually very, very interesting. So the tool is out there. Feel free to play with it, experiment with different sentences. And yeah, so this is it about LLMs. We have seen that they are actually just classification. They are solving a classification problem, so there is no magic happening there. They just predict the next token. And in the next video, we will show how they actually work in a loop in order to predict multiple tokens. So that's it for this video. I hope you found that useful, and I'll see you in the next one.